Okay, so something huge just went down at the intersection of AI and astrophysics. Seriously. A team of researchers just used artificial intelligence to pull off something that, until right now, was pretty much considered impossible. They've built our entire galaxy inside a computer.
100 billion. Just let that number sink in for a second. That's how many stars are in our Milky Way galaxy. And for the very first time, scientists have actually managed to simulate nearly every single one of them. This isn't just a small step forward, folks. It's a massive leap over a computational wall that scientists have been staring at for decades. Think about what that really means. A complete one-to-one digital model of our home in the universe. Every single star, from our own sun all the way to the most distant tiny red dwarfs, it's all there, captured in one massive simulation. So the big question is, how in the world did they pull this off? To get what's going on here, we gotta look at the incredible work of an international team from Japan and Spain. And believe me, their goal was ambitious, to say the very least. You know, for ages, astrophysicists have had this dream of building a truly lifelike model of the Milky Way, a kind of virtual laboratory, right? Where they could test all their biggest ideas, like how do galaxies even form? How do they get those beautiful spiral arms? And how do the very elements that make up you and me get created in stars and spread across the cosmos? The problem? Well, they kept hitting a wall. And we're not talking about a small wall. We're talking about a massive computational wall. See, building a galaxy in a computer is insanely complex. You have to simulate gravity, the way gas moves, and of course the explosive deaths of stars, all happening on these wildly different scales of time and space. And that's where things got really, really tricky. All right, check this out. On the left, you've got the old way of doing things. The absolute best simulations could only handle about 1% of our galaxy's stars. And get this, their smallest particle wasn't even a single star. It was a cluster of 100 suns all smushed together. This meant that super important fast events like a supernova explosion, they were just averaged out, totally lost. It was like trying to watch a 4K movie on a single pixel. You just can't see what's happening. Okay, now let's really dig into these numbers, because this is where it gets crazy. This table shows that impossible walls scientists were facing. With the old methods, just to simulate 1 million years of galactic time, it took 315 hours. So what if you wanted to simulate 1 billion years, to see how things really evolve? You'd have to wait more than 36 years for the computer to spit out the answer. It was basically impossible. Now look at the AI column. That same million years, less than 3 hours. And that 36-year wait, it's now just 115 days. That's not just an improvement, that's a total game changer. So, what was the secret sauce? How did they break through that wall? The answer is a totally brilliant AI shortcut. Instead of just trying to brute force all the math, they taught an AI to do the heaviest lifting for them. They used this really clever thing called a deep learning surrogate model. What does that mean? Well, think of it like this. They took an AI and had it watch thousands of super detailed simulations of one specific really complex event, like a star exploding. The AI just watched and learned over and over until it understood the physics so well that it could predict the outcome all by itself. It basically became a super fast expert that could replace those incredibly slow, difficult calculations. Okay, so here's how they did it step by step. First, they trained the AI on nothing but supernova explosions. That was its whole education. Second, the AI got so good it could perfectly predict the aftermath, how all the gas and energy would expand for the next 100,000 years. And then the brilliant part, step 3, they dropped this super smart AI into the main galaxy simulation. By letting the AI handle the single hardest, most time-consuming piece of the puzzle, the entire simulation could suddenly run hundreds of times faster without losing any of the detail. And they didn't just run this on a regular laptop. They plugged this AI brain into some serious hardware. We're talking a combined 7 million CPU cores on Japan's Fugaku and Miyabi supercomputers. To put that into perspective, the Fugaku supercomputer alone can do more calculations in 1 second than every single person on Earth could do in an entire year. Yeah, this is the perfect marriage of AI smarts and raw computing power. Now, you might be thinking, okay, this is amazing for astronomy, but what does a simulated galaxy have to do with my life down here on Earth? Well, it turns out a whole lot more than you might think. See, this breakthrough isn't really just about space. It's a blueprint. It's a whole new way to solve some of the biggest problems we face right here at home. Any problem where tiny little events add up to create huge, large-scale outcomes. Think about climate change. How does one factory's pollution affect global temperatures over decades? Or weather prediction. How do tiny water droplets in a cloud turn into a massive hurricane? This exact AI technique could be the key to building way more accurate models for all of those fields.
So what this really represents is a fundamental shift in science itself. By using AI to build a bridge between the microscopic world and the macroscopic world, these researchers have handed us an incredibly powerful new tool, a tool to understand the complex systems that shape not just our universe, but our entire world.
Which, brings us right back to the big picture. Because this isn't just some technical achievement. It's a brand new chapter in our species' long quest to figure out where the heck we come from.
The lead researcher, Keiya Hirashima, put it perfectly. He said, "This is a genuine tool for scientific discovery. With it, we can finally start to trace the cosmic journey of elements like carbon and oxygen, from the moment they're born in the violent heart of a star to their long journey across the galaxy, all the way to their arrival right here on Earth, where they became the building blocks of you and me."
So, we now have a blueprint for creating digital twins of these unbelievably complex systems, from our home galaxy all the way down to our planet's climate. That massive computational wall that stood in our way for so long, it's been completely shattered. So the only real question left is, what do we choose to understand next?
Thanks for watching. Before your Wi-Fi drops, hit that like, share, and subscribe button. Stay sharp, stay curious, and keep guarding the trends.